the last class we talked about, we said the limit of 1 over x minus 1 as x approaches 1 from the right is infinity, and the limit of 1 over x minus 1 as x approaches 1, there's supposed to be a 1 right there, 1 from the left is minus infinity. Okay, so we just said that last time. And if you look at this, if you plugged in a 1, you're going to end up with 1 over 0, and we said 1 over 0 is infinity. Well, why? Well, we're going to do that proof here in a second. But what you look at any time, and I'll say this again when we get through some more problems, any time your denominator is going to equal 0 at that limit, who cares left or right, don't even think about that yet. If I plug in that number, if my denominator is 0, any time your answer is going to be plus or minus infinity. So if you end up with a 0 in the denominator, now you get out your coin and you flip it on your test, right? You got a 50-50 chance. Here, if you just logically think about this, if I'm coming from the right-hand side, meaning I'm getting values greater than 1, so this is going to be positive. If I'm coming from the left-hand side, I'm getting values less than 1. If this is less than 1, when I subtract 1, this is going to be negative, and that's how you figure out if you have a positive or negative value. All right, so now what I'm going to do is say, well, if I have, for example, prove the limit of 1 over x squared as x approaches 0 is infinity. All right, and again, you know that if I plug in 0, I'm dividing by 0, and I end up with 1 over 0, and of course, if I'm heading towards 0, whether it's positive or negative, I'm squaring it, so that's why this is positive. So to prove this, I'm going to say then for all real numbers, just going to write real mathy to not have to write a lot. If I have some value b greater than 0, say that's my limit, okay, then we must find some delta greater than 0, that's my interval, such that for all x, this implies, okay, this is my, should look very familiar to you, where we just said that's where you're centering it. It's your interval, okay, but we called it where you're centering it, implies that f of x is greater than b. So as you're writing that, what's all them weird-looking things mean? Well, this just basically says you have some limit. I'm going to tell you my function will always be greater than that. Whatever you pick. Well, then that means this is heading to infinity. So if we can show this, well, if I start out with my f of x greater than b, where I see an f of x, I plug in 1 over x squared. So that's all I've done is just simply plugged in my actual function. And now what I do is I flip or do 1 over the reciprocal, so I have to flip that as well, b. And then you kind of get out of the habit of it when you take square roots. You're really supposed to be doing plus or minus or absolute value of this side, and I'm square rooting that side. Well, the square root of 1 is just 1, so I could rewrite it like that. And so all I would have to do then is choose, because this is my x value, so in my x interval, then just choose my delta to be this value, or I could even have a smaller interval, okay, as long as I don't go above that. So then, using my definition, 0 less than absolute value x minus x naught, less than delta. Way up here at the top, there's my x naught, 0. So I just simply plug that in, 0 less than delta. And so I just simply get my absolute value less than, we said choose our delta to be that. So 1 over square root of b. Well, this same thing implies if I flip it back, if I work backwards from what I did here, and I flip everything back, I end up back with 1 over x squared. And the absolute value means, I don't have to put the line here because I'm absolute value in it. It's probably not too wrong to put it there. But I'm saying greater than or equal to. And in this case, this is my definition. That's what I wanted to show. I wanted to say, I don't care what you pick for your limit. I will always say that my function, which is this function, will always be greater than it, meaning that the function is just heading off to infinity. Now, for you now, we're to the point where, okay, there it is, we're going to just use it. Now, in my math lab, some of the problems towards the end ask things like, what's the horizontal asymptote? What's the vertical asymptote? And it went back to your algebra days, you know, just by answering it. So let's kind of do a reminder of vertical asymptotes. What I tell my students when I teach this like in algebra is you just say it's what's not in the domain, because you've been programmed so much of what's the domain, what's the domain, what's the domain. Well, if you can figure out what the domain is, then what's not in the domain is your answer. So for example, if I said find the vertical asymptote of 1 over x, well, first, tell me what the domain is. What? Okay, so, or it could be written like this. In other words, oh, you want a 0 there. In other words, x can equal anything except 0. Well, that's my not in the domain, so that's what my vertical asymptote equals. So what's not in the domain becomes my vertical asymptote. If I had y equals x squared plus 4 over x minus 3, what's the vertical asymptote? 3. Yeah, so in other words, you were taught and you learn, you just look at the denominator and what makes the denominator 0. So hopefully that's kind of a reminder of how you find vertical asymptotes. There might be times that you have to factor that, okay? And then basically what you're doing is you're setting your denominator equal to 0 and solving for your variable, okay? And that gives you your vertical asymptote. All right, so now let's throw this into a limit and say, well, what's the limit of this as x approaches 3 from the left? I'm sorry, why'd I put a 4 there? And it ain't gonna let me erase that, so pretend that that's a 3. My eye was still looking at the top 4. All right, so if you've been listening, I said if you plug in that limit and you get 0, your answer's positive or negative infinity. You got a 50-50 chance. What's your answer? I hear negative infinity. Okay, so I know right away it's infinity. It doesn't hurt to look at this and say, okay, if I'm at 3, that's what I'm trying to approach. That means as I'm getting close, I'm picking values down here, like say maybe 2.9. That's pretty close. If I plug that in, then this bottom becomes negative. So a lot of times you'll see me write this, well, who cares what you plug in there? That's going to be positive. That's going to be negative, and thus, put that in there, my answer is going to be negative infinity. So if I have the limit of x squared plus 4, x minus 3, as x approaches 3 from the right, is that plus or minus infinity? Plus, because I'm looking at, again, here, if I plug in 3, 0, so I know I got 50-50 chance again. I'm looking at values to the right now, so I don't know, how about 3.1? That would be to the right of it. And if I plug that in, that's going to be larger, okay, than this value. And again, who cares what's happening on the top? So then what would the limit of x squared plus 4 over x minus 3 as x approaches 3 be? Why? Does not equal the right hand. And that's on the, like on a quiz test or something, I would say for you to say why, and that's good enough. Well, not just saying that, meaning you would have to show what the left-hand side equals, what the right-hand side equals, and just show there that these two values, sorry, that negative's in there, these two values were not equal, and thus the limit does not exist. Okay. A kind of an other, not really a review, but a reminder, because students get these mixed up a lot. Remember the horizontal asymptote was when we had our function heading to infinity, because what's happening, the bottom here is getting very, very large, meaning that we're going to have 1 over a very, very large number, which is a very small fraction, basically 0. And then if I have my limit of 1 over x as x approaches minus infinity, well, again, we could say that's getting very, 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 very small negative, and again, we're just simply going to 0. I thought, man, you know, if this was real life, this would be cool, because this says as my bottom gets bigger, it's basically going to 0. That was my math humor of the day. You didn't get it, fine. If you laughed, add 10 points to your quiz today. And just write, I laughed. All right, and then the vertical asymptote is where you're actually approaching a number, a value, but these are what's heading to positive and negative infinity. Probably this is a lot easier to see that whole deal of what she's talking about, plugging in numbers. If I'm to the right of 0, those are positive values. If I'm to the left of 0, those are negative values. So that's that whole deal that I was saying, pick values close. Certainly zeros are, you know, nice ones because they're good and easy to pick. All right. I always ask students, you know, did you read on Blackboard the message that I sent out? And the answer I always get back is, yeah, I saw it, but I didn't read it. Okay, so if you read it, then you probably know this already, is you're always looking at highest power, that's a P, in your denominator when you're working most of these. There are going to be some little tricks, though, that sometimes you're just looking for the highest power, because that tells you what to dominate in your function. All right, so, and then I said, well, if you see your degrees of the numerator equals the degrees of your denominator, then your limit is just simply the ratio of the coefficients. If I have the degree of my numerator is less than the degree of my denominator, then my limit's 0, which is what McKenna figured out last class. It's like, well, I see that this is, and that was right. I mean, she figured that out on her own. And then, so if the degree in the numerator is greater than the degree in the denominator, this is where you're going to end up with that plus or minus infinity. And again, a lot of it's going to, we can say, well, what's dominating? Well, whatever's dominating, what is in front of it if there's a negative sign? So I was given an email of a problem, and I am going to embarrass you, and I'm going to work at Patrick, and then I want you to tell me your thinking, okay? Because your thinking may, one, be better, that students understand it. And so here is my math lab problem. The limit of 1 minus x to the 4th over x squared plus 6x to the 5th power as x approaches minus infinity. All right, the very first thing I look at is above steps 1, 2, and 3, and this applies to which one? 3. So my answer is plus or minus infinity. Once again, I guess it would have helped if I would have written an infinity there. Once again, I have a 50-50 chance of getting this right. So that's my step one. My numerator is greater than my denominator, so I know my limit is plus or minus infinity. It at least gives you something to go with. Then what I do is I look to see what's dominating this, meaning that if I plug in this value, one could care less about it. You want to add 1 to infinity? Have at it. You know, what do you think that's going to do? Infinity plus 1, right? What is that? Little kids will say that. I love you, infinity plus 1. Yeah, I don't know. I don't get it either. Because you can't add 1 to it. Not a real number. Yes, I tell my nieces that. And so this really is meaningless. So I'm looking at the largest exponents. That's the largest, so that's dominating. That's king. Who cares if you want to square it? I'm going to put it to the 4th power. So in other words, the next thing you look is for the, I guess we could call it the dominant or highest degree, which is my x to the 4th. But you need to notice that there's a negative out front there. Now, and I'm thinking of Sarah about this part. For you math nerds out there, normally it tears up a math nerd to say you can't say negative, or you can't say infinity to the 4th power, because we just said it's not a real number. How are you going to do, can you say infinity plus infinity? Well, no. Technically, you can't say that. But we can do something a little crazy and say, isn't this the same thing as that? Okay, that -1 is not attached to that, or I'm sorry, that negative is not attached to that x to the 4th. It's out front there. So if I look at this inside right here, this tells me that now if I plug in, if I look at my power here that I'm plugging in, and I plug in, just bear with me doing this unreal math, that actually is going to make that positive because you have an even power. Just like, I know you don't like that, just like the real world, if you have a negative value and you put it to, I said positive, to an even, because that's even, then this becomes positive. You still have the -1 there. And so I end up with negative infinity inside, but wait, there's more. There's still a 5th power there you have to think about. Because this is odd, then we stay with my answer as negative infinity. I can already tell Patrick doesn't like that, so tell me how you thought about this problem.
No, when I did this, we were still doing the thing where we
Divide every term by x squared.
That's what I was thinking that way.
There's nothing wrong with that, so you're going to end up with x to the 4th over x squared, which is going to be x squared, but you can't lose, because everything else is going to 0, or x squared over x squared is 1. You can't lose that negative sign.
Yep.
And so you ended up with a negative x squared. And if I plug in, again, minus infinity, a lot of times students will just say, well, minus and a minus is a positive, but the problem is you have to, when you plug in minus infinity to your square now, that made it positive, and then you still had that minus sign there. There's nothing wrong with that way.
Well, my question was, when you divide all of them, when you divide like x squared?
X squared. You always divide by the denominator highest, yeah. So basically, and this is what I actually would want to see on the test today, let's do it that way. So what he did is he took and divided every single one of these, I'll just do it in this step, by x squared. Again, why by x squared? Because that's the highest power in the denominator. And you're doing that because you're trying to get these things to go to 0. So x squared over x squared plus 6x over x squared. And this is more of the, Cindy said I had to show my work way, okay? Anything which we just showed this, but I'm going to put a circle around it, but that means that's going to 0. That's going to 0. That's becoming 1. So I end up with this limit as x goes to minus infinity of a negative. That becomes x squared, what, just over 1. Okay, so now I say, well, let's go ahead and do the whole thing, the fifth power. Now I say plug in my negative infinity there. This is the minus sign, negative infinity squared. This becomes positive, so I end up with this minus sign still. Fifth power is odd, so I still end up with minus infinity. So, I mean, there's nothing wrong with that way. In fact, that's the correct way.
No, I think I just did it by x to the fourth the first time.
The fourth,
Like,
okay.
weird.
But it's eventually I want you to get to the point, and you'll probably see more stuff like this, that you really want to start to look at this logically and say, well, logically, this is going faster. Who cares if you're going to square it? This is the dominating power right here. So this is really all I have to look at. I don't have to look at anything else in this entire problem. And again, you know, it kind of helps you get through these, you know, certainly in my math lab quicker. So let's do one that looks like it to see if I can trick you here. Of course, if I say trick you, then you might know the trick. As x approaches minus infinity, what do you think the answer is? What is it? Negative infinity? Why? Very good. So I didn't trick you. He noticed up here I had an even power. And so here, this is going to be an odd power. Do you want to rethink your answer of negative infinity? Because what's going to happen now up here, don't forget that negative. You're going to have the negative of the negative infinity to the third power. That's going to stay negative, right? Because it's an odd power. Then you have that negative. And since it's to the fifth power, it stays negative. The only other thing we could do to really mess this up is say, well, what if I made that to the fourth power? Then, I know you hate when teachers do it. You hate when teachers do this right over their own notes. Then it would become positive. So you're looking at powers, basically. Okay, once you get through, and as I mentioned before, ignore that until the very end. It did help a couple of students today, and you know, it's kind of funny that, oh, I didn't do anything with that, you know, type deal. Just don't, even though I'm saying ignore this, don't forget it your last step, because then what if that was an even power?
It's not positive.
Yeah,
Oh, that's a positive. Extra points. Yes.
So you wouldn't accept it like on the test? Where you have to
I either would say show why, and then that means you have to do that way. Or if I just say give an answer, but not just saying by a graph or something. If you want to say, meaning these steps right here would be fine for me. Would be good enough,
Or you have to prove anything?
No. I know how much y'all love proofs, and I know that disappoints you, but, you know, yes, no. All right, so how about the limit of x minus 3 over x squared? All I'm going to do is just work a bunch of problems now. As x approaches 2 from the right. I know the answer is plus or minus infinity because the denominator is 0. So is it plus or minus? Let's see. There's nothing wrong with, even though you might say why, because it's not doing anything for you, of factoring this. What it does for me is it makes me look at, not get too wrapped into that square thing. So again, if I'm approaching 2 from this side, I'm getting very, very, very close to 2. Well, I don't know, 2.1 is pretty darn close. If I plug in 2.1 here, 2.1 here, 2.1 here, the top is going to be negative, the bottom is going to be positive times a positive, and I think my answer will be negative infinity, because there's only one negative. So that's how you kind of look at these. Again, right away, my denominator is going to be 0, my answer is plus or minus infinity. How do I figure out which one? And if you just did this technique where you just plugged in here, this step, then you would say, well, that doesn't make sense because this is going to be positive, but the key is noticing up here that this value is going to be negative. So if I had the limit of x minus 3 over x squared minus 4 as x approaches 2 from the left, do your same theory here. Again, and sometimes I'll do another example where something actually cancels here at the bottom. But again, I'm looking at values on this side, so I don't know, how about 1.9? So I'm looking at each one of these x's, and I'm looking at values very, very close. You don't want to pick something way, you might say, well, why not pick 0 or something? You want something close. Why? Because that's what a limit is. It says what's happening as I get close to 2. Well, this is certainly really close. Notice what's happening up here in the denominator. That's going to be negative. The numerator, that's going to be positive. But now this one's going to be negative, and a negative over a negative gives me my positive infinity. But at least get to the point where denominator 0, I have a 50-50 chance. I mean, that you should already be at. If the denominator becomes 0, anything over 0 is going to equal a plus or minus infinity. Then I pick values close to that to see. Now, if this is a problem, if I just flat out give you this on a test, x squared minus 4, and we know from our last example that this does not exist because the left-hand side does not equal the right-hand side, and this might be what you're asking, is there a proof? This, to me, would kind of be prove this does not exist. But how you prove it is by finding that the left-hand side and the right-hand side aren't equal. Okay? So it's not like a formal type proof, but it would be a way you can prove it. All right, so if I have the limit of x squared minus 3x plus 2 all over x cubed minus 2x squared as x heads to 0 from the right. Denominator is going to be 0 plus or minus infinity. Just as you learned in algebra, make things simpler. Meaning, if you can factor some things, do it. It just makes it easier to why have to plug in numbers all over the place. So I can factor the top into x minus 2, x minus 1. I can factor an x squared out of the bottom, and it just makes this a little easier now. All I'm dealing with are these values. If I'm approaching 0 from the right, I don't know, 0.5, that's less than 1, so that top is negative. This doesn't matter what you're doing, that's always going to be positive, and so I end up with my negative infinity. Okay, this step right here, I already knew that was my answer. Then it takes the logic, that part, and this would be a way to prove this, is show me that you picked some values here, okay, to plug in to see what you were actually getting close to. This one's kind of weird, and it makes sense, but I don't think most of you would have thought to do this on this problem. So I have the square root of x squared plus 1 over x plus 1 as x heads to infinity. And you're on Cindy's test, and she says right away you have to show all your work. What are you going to divide every term by? X squared? What's the highest degree in the denominator? X. Okay. Isn't x the same thing as the square root of x squared? Oh my God, why would you want to do that? I don't know how many of you would want to divide this by x because, okay, now I don't know what to do. If I put in a square root, I can combine those square roots, and that's what I'm going to end up doing. So this is what my math lab told you to do. Again, it's one of those, well, how would I know how to do that? I would think when you did this piece here, you would sit there and say, okay, now what? I don't know what to do. But if I can make this look the same, and then of course the bottom, who cares? Let's leave that as x. That's still the square root of x squared is x. And so then what I do is I take every single one of my terms, and I'm going to kind of do this in 2 steps. I'm going to make that one big fraction, one big radical, and divide each individual term by x squared. So all I've done is each individual term, and then on the bottom, I'm going to divide each one by x. And now away I go to do my work. I know that if I have, well, this piece right here, of course, is going to be 1. I know that if I have this piece here going to infinity, squared, whatever, very, very large value, this is going to 0 because the bottom again is getting very large. This is a 1. And then this piece right here, of course, is also going to 0. And so as I see, all I have left is the square root of 1 over 1, which gives me 1. So my question is, how many of you recognized from this step right here, you could have told me the answer that quickly? When the powers are the same, if I take the square root of x squared, when the powers are the same, you take the ratio, got time to buy a new calculator. You take the ratio of those coefficients and you get your answer. You know, and again, but you said I got to go through all these steps. Well, yeah, but at least you'll know if your answer's correct if you have all these little shortcuts, you know, kind of in your head.
Wouldn't it have been wrong just to simplify it in the numerator? See that it cancels out?
Well, my question would be, how do you simplify that? Because you can't separate it. You can't say the square root of x squared plus the square root of 1. So there's not really anything you can do to simplify. I'm doing it in my, and you're going, but that's what you did. I'm doing it in my head because I'm saying, once again, when you're heading to an infinity, we really don't care about that 1. So technically what you're saying, yeah, if I don't care about the 1, then all I have is a square root of x squared, which is x. Yeah.
Yeah, I don't care about the square root because I know it's going to be root 1 over root 1.
Exactly, over root 1, and then that would give me my ratio. Yes, yes. Let's see, with the recognizing, like you're mentioning, if this one, the limit of x minus 3 over the square root of 4x squared plus 25 as x approaches infinity. So I agree with your theory. What's the answer? What do you got to do with that 4, though? Be careful. Yeah, you got to square root it. So in other words, the answer is 1/2. Because if I take the square root of 4x squared, that gives me 2x. That's the same power. I have a 1 at the top, and I have 2x on the bottom. So same power. So my answer is 1/2. Well, again, that makes my math lab happy. That makes Cindy sad. I want to see your work. Meaning that I'm going to take each one of these and I'm going to divide by what? Square root of x squared. Okay, you can't pull it out, you know, and I only want to mention that in case like this whole thing was cubed, you know, or something like that. So I'm going to take each one of these terms and divide by, or you could say x, same thing. And so each one of these terms divide by square root of x squared. Here, 4x squared. And you can see that's where that's happening, that piece. And then 25 over x squared. Once again, if you write these as x's, just because I'm lazy, I don't want to rewrite all this. All that becomes x's. That's over an x, that's going to 0. That becomes 1. This is over an x squared, that's going to 0. So all I'm left with here is 1 over the square root of 4. That goes away. which becomes 1/2. But what you could see from the very beginning. And so my answer on something like that would be, well, it's nice to be able to look at this. It's kind of like those of you that have had derivatives before. When we get to derivatives, we're going to take this long route to find a derivative. Those of you that had this in high school say there's shortcut ways to do it. But you learn this long route, and then you say, well, I can check it, though, because of knowing the shortcut here. And, of course, in my math lab, you can get through your problems very quickly. I haven't really worked too many things with trig functions, so I want to throw one of these out there. The limit of 1 plus cosecant theta as theta goes to 0 from the left. Now, I always tell my pre-cal students, secants, cosecants, cotangents, don't like dealing with them. Change them to sines and cosines. So what's the cosecant? 1 over what? Sine. So this is going to be 1 plus 1 over sine of theta. All right, once again, I can see if I plug in a 0 there, I end up with 1 over 0. I don't really care about that 1 because I know I end up with a 0 in the denominator. There's my answer, plus or minus infinity. My answer looks here and says if I'm plugging in negative values, and I know your brain is conditioned to pi over 2, and you could just plug in a negative number, negative 0.05 or something, then this piece is actually going to end up being negative, and thus I end up with my answer. So all of these, what you're looking at is you're looking to see what can you plug in. Well, once you figure out you're getting a 0 here, then what can you plug in close to that to see if you're getting a positive or a negative value. If I have the limit of 2 square roots of x plus x to the negative 1 over 3x minus 7 as x heads to infinity. If you go back and you wrote them down, those 3 little step things, I said, well, if I look at these, sorry, that's not it. If I look at the 3 steps that I give you, it said if the degree in the numerator,
Is that negative 1 is a numerator?
that's an exponent. Yeah, an exponent. So I look up here and I say, well, the degree in the numerator is less than the degree in the denominator. My math lab, I'm done. I would like you to get where you can work these that quickly that you recognize these little tricks. But then once again, on the test, you're going to divide every term by what? X. Because you look at the denominator. So I take every single one of these terms. I'm going to go ahead and write that to the 1/2 power. Just makes it easier when I'm subtracting my exponents. X to the minus 1 over x. 3x over x minus 7 over x. Hopefully you kind of remember some of these rules, which I just mentioned. If the bases are the same, you subtract, and there's a 1 there. So I'm subtracting, which is going to become a negative 1/2, which I can rewrite the limit as x goes to infinity. In other words, in this case, if I'm looking, I'm going to go ahead and write that in the denominator, because I like my x's in the denominators, because that makes them go to 0. And then this becomes 1 over x squared, y, that's negative 1 minus that 1. So negative 2, brought it to the denominator. This, of course, just becomes 3, and that stays 7 over x. Everything going to infinity, the denominator's growing large, 0, 0, 0, 0 over 3 gets me my original answer. Okay, and so this is the show me part, and this is the I just want to get my math lab homework done, and also this is, will I at least know I did it right? And always have students, I have a student in my other class that he will go through my math lab and he will hit, he'll just put a 3 or anything in, and just get the answer, and so he kind of reverse engineers, works backwards. Well, that's what you're doing here. You already know what your answer is, so you're kind of reverse engineering it to make sure you actually get that answer. Where are we at on time? Trying to pick out some of the better ones here. If I have, well, just something very basic, as x approaches 0 from the right, what's that answer? Positive infinity. Because if I plug in a 0, I have an infinity. If I'm to the right of 0, I'm only at positive numbers. How about the limit of 3x over 2x plus 10 as x approaches minus 5 from the left? If you have to take the trouble, you're on a number line here, I'm approaching it from the left, plug these values in. If I plug in a -6 there, a -6 there, the top is going to be negative. The bottom, if this is -12 plus 10, is going to be negative. Negative over a negative gives me a positive. This is probably the best route to do instead of, just staring at it and trying to guess, is it positive or negative, is by doing this by plugging in, again, values. Now, this last thing that I'm going to do is I just had a student ask me, because it's been a while and getting ready for the test, this is way back in 2.1. So just kind of a reminder, because I wrote this in that wonderful review that I give you. Find the slope of a curve at a point and then find the tangent line. What's going to be kind of nice, and I'll show you here in a minute, I'll say it here in a second. Here is my function. Here is my point. Now realize I could have just said, because I do this sometimes, I'll just say at x equals 1. Well, you can find that point by just plugging in a 1 there. So when we find a slope, well, we know we need the slope formula. So that was our slope formula, okay? In chapter 3 that we'll start on Monday, you're going to use this same exact formula. The only difference is we're going to stick a limit on it. So it'll be kind of nice that, I know students say, I don't want to learn anything new that's not going to be on the test. It'll be kind of like what's on the test. We're going to do an extra step. So here, I'm going to just simply plug in my 1 because students kind of like to see what am I actually plugging into my function for x. And those are the values I'm plugging into my function. So my function is 5 minus x, which is 1 plus h squared, minus 5 minus 1 squared, or if you're paying attention, that's just that value. Okay, so you're already given that, all over h. And now it's just fun algebra time. Meaning all you do is square this piece at the top, square the first, 2 times the middle, square the last. Of course, this becomes minus 4. And this equals, let's go ahead and just distribute out that negative. If that did not happen, and you are not only left terms in h, then you need to back up and check your work. This will always happen, okay? So meaning that I end up with minus 2h minus h squared over h. I can now factor out an h on the top, so I have negative 2 minus h over h. That cancels. And then we say the point of what we're doing is we're letting this go to 0, so I get my answer. What is that number? What's negative 2? Slope. So I have a slope. I have a point. I know how to find a line by what formula? point slope, y minus y1 equals m times x minus x1. My y1 is my 4, my slope I just found, and then minus 1. For me, you're done. You know, this whole, well, don't we have to solve it for y? Why? You know, if you want to put it in your calculator, sure. But for me, I would move on to the next problem at that point, okay? And again, that was just